We start with a historic mission to the moon and the launch of India's Chandrayaan-3 spacecraft. This is the moment that it took off just under an hour ago. It entered Earth's orbit shortly after.
India's Chandrayaan-3 mission made history with its landing near the moon's south pole, a proud milestone for the nation's space program. But the real shock came from what the rover found beneath the surface. Long believed to be perfect for future lunar bases thanks to water ice and stability, the region revealed unsettling surprises. Subsurface scans showed strange mineral mismatches, abnormal radiation spikes, and unexplained electromagnetic interference, not just instrument errors. Most puzzling, radar bounced off an unusually reflective layer, yet thermal scans showed it absorbed heat unnaturally. This discovery challenges everything scientists thought they knew about the moon's untouched southern frontier. The strange layer acted like a heat sponge, soaking up sunlight but refusing to release it normally. That alone could mean thermal instability, making future lunar bases far riskier than planned. But deeper, around 2 to 3 meters down, sensors picked up sudden neutron radiation spikes, far above expected levels. This wasn't random cosmic or solar radiation. It pulsed in a steady, almost mechanical rhythm. The pattern was too clean for natural decay, looping predictably every few hours, as if a hidden clock was ticking beneath the moon's skin. Experts were stunned. Whatever was generating this energy wasn't coming from space. It was coming from inside the moon itself. This wasn't just another scientific twist. It confirmed a fear scientists had whispered about for years. The moon's polar regions might hide forces that defy everything we know. Not aliens, but alien rules. Materials or energy sources behaving in ways Earth science can't explain. Chandrayaan-3's findings threaten the very foundation of future lunar base plans. Sure, water ice may be there, but if it's sitting on top of radiation-emitting layers, it's a deadly resource. Suddenly, stable terrain and manageable radiation aren't guarantees. The moon, humanity's first cosmic milestone, now looks far less welcoming. If our closest neighbor hides such hazards, what dangers might be waiting on Mars or Europa? This changes the game. Global space agencies, NASA, ESA, JAXA, and private spaceflight giants are now scrambling to rewrite their moon plans. Radiation shielding must be tougher, mining operations delayed, and rovers redesigned to survive harsher than expected conditions. And then came the strangest twist: electromagnetic dead zones. As the rover moved across certain coordinates, its signal would glitch and cut, only to return after leaving the area. No craters, no boulders, nothing visible, just empty land that swallowed communications. On Earth, magnetic anomalies can be explained, but the moon's south pole shouldn't have any. Yet here they are. If these lunar Bermuda Triangles are common, future missions could face catastrophic blackouts at the worst possible moments. The timing couldn't be more unsettling, just as NASA's Artemis, China's lunar program, and private giants like SpaceX and Blue Origin set their sights on the moon's south pole. Chandrayaan-3 drops a bombshell. This was supposed to be the prime spot for future space hubs. Now it's a question mark. The strange, consistent anomalies hint at something hidden deep below. Maybe geological oddities. Maybe something less natural. There's no hard proof yet, but the data is too sharp to ignore. The moon's calm, predictable image is crumbling, replaced by a picture of a complex, unpredictable, and possibly hazardous world. If its southern crust truly holds alien materials, our entire approach to lunar exploration could change overnight. Chandrayaan-3 has uncovered a part of the moon unlike anything seen before. Strange radiation bursts, bizarre electromagnetic shadows, and heat patterns that make no sense. All pointing to a south pole that's not just harsh, but fundamentally different in makeup. Scientists now suspect unknown minerals or composite substances may be hiding just beneath the surface. Physicists are puzzling over the radiation's origin, while engineers race to design systems that can survive in an environment that scrambles signals. The moon is no longer a blank, predictable world. It's a volatile mystery. And here's the kicker. The rover only scratched the surface. What's buried deeper could be even more shocking. This marks the start of a new, and possibly unsettling, chapter in space exploration. The real shock isn't what Chandrayaan-3 found, but how unprepared we were for it. Decades of missions painted the moon as dead, uniform, and predictable. Until now. The anomalies were locked to precise zones, repeating like patterned hotspots beneath the surface, not random quirks. That means something systemic is at play. Thermal scans showed materials whose heat behavior changed with the sun's angle, unlike anything seen on the moon before. Scientists can't match these readings to known minerals, leaving us with a haunting truth. The moon may be far stranger than we ever imagined. These strange zones seem to change their heat behavior depending on the sun's angle, almost like they're engineered on a molecular level. Yet, to the naked eye, it's just plain lunar dust. No color shifts, no surface scars, nothing to hint at the intense radiation and energy happening below. Instruments suggest these hidden structures have been there for millennia, yet they show signs of recent, active processes. That's the real shock. The moon's south pole might not be geologically dead after all. Some experts now whisper about pockets of localized activity, energy bursts, particle emissions, and exotic mineral reactions. If true, the moon isn't a silent rock, it's a dynamic system, and that changes everything. Any moon base built here could face unpredictable heat and radiation spikes, with one site staying stable while another, just kilometers away, falls apart. Astronaut safety becomes a nightmare as radiation pulses outside normal solar patterns could hit without warning. Safe zones once mapped out may now need costly shielding and constant monitoring. Even rovers and satellites aren't safe. Hostile terrain could fry hardware and erase mission data. Chandrayaan-3's discovery isn't just science. It's an engineering crisis in the making. And the stakes are political too. The South Pole is the most sought-after real estate in space. Now, every nation aiming to land there must rethink its plans. Fast. If these anomalies pose long-term risks, the moon race could shift from who lands first to who understands it best. Tech and science will outweigh raw speed, and nations without advanced mapping and sensors could be left in the dust. Legally, it's a nightmare. Current space treaties assume celestial bodies are harmless. But what if a base built over one of these zones causes another country's gear to fail from radiation leakage? Chandrayaan-3's data has even revived once-dismissed theories about hollow structures, strange magnetic cores, or buried relics of ancient processes. Whether natural or not, these anomalies force us to face a chilling truth. The moon may be far more complex and far less safe than we ever imagined. The moon's new mystery zones have changed everything. Future missions won't just map the surface, they'll dig deep into the danger spots. Plans are forming for burrowing landers with core drills, particle detectors, and sensors built to survive extreme radiation and electromagnetic chaos. For decades, exploration was about rovers covering ground and snapping photos. But Chandrayaan-3 made it clear, the real story is underground. The clock is ticking too. No one knows if these anomalies are stable or evolving. Radiation spikes could grow, heat patterns could shift, and EM interference might spread. The race is no longer just to explore. It's to uncover the truth before the moon changes forever. For the first time in decades, lunar planners are pulling back with caution. The South Pole is no longer just a gateway to the stars, but a gatekeeper demanding answers before we pass. Astronaut training is being rewritten, spacesuits upgraded with heavier shielding, and habitat designs reworked to include underground bunkers and EM-proof command centers. Chandrayaan-3's data still pours in, and AI analysis hints at a bizarre spiral pattern of anomalies beneath the crust, possibly ancient force lines or hidden flows. Now, upcoming missions face a stark choice: steer clear and play it safe, or head straight into these mystery zones and risk everything for the truth. Either way, history will remember. Avoiding these zones might keep astronauts safe, but it also keeps us in the dark. Investigating them could unlock groundbreaking science or trigger disaster. Chandrayaan-3's findings have shattered the Moon's long-standing image as a safe, silent neighbor. For decades, it was our friendly stepping stone to the stars. Now, it's showing traits we never imagined. Among the strangest discoveries were subtle but persistent gravity distortions, strong enough to throw off the rover's navigation. These weren't the massive mascons scientists mapped years ago, but tight clusters with odd vertical shifts, hinting at hidden underground masses or cavities where none should exist. Whatever's under there, it's rewriting everything we thought we knew about the Moon. These hidden gravity pockets change the game. Landers and rovers rely on stable pull, and even a slight anomaly could send a descent path drifting in the final seconds, risking crashes or tilted landings. Chandrayaan-3 also uncovered another curveball. The soil itself isn't behaving normally. Some spots, though smooth on the surface, collapsed into fine, fluid-like dust, while others hid rock-hard layers just centimeters down. This mix of sinking traps and near-impenetrable crust suggests unknown chemistry or electrostatic forces at play. For astronauts, a wrong step could be dangerous, and for engineers, every base design just got harder. The South Pole's safe terrain is now a risky patchwork of unpredictable ground. Not all anomalies hide underground. Some lurk in the Moon's still airless environment. Chandrayaan-3 detected faint, low-frequency tremors with no clear cause. Not from impacts, not from thermal expansion. They were sporadic, pinpointed to exact coordinates, hinting at hidden subsurface shifts or microfractures in unknown materials. Even tiny movements could destabilize telescopes, antennas, or power stations, throwing precision systems off balance. Stranger still, orbital satellites saw nothing. The electromagnetic disturbances PN detected never showed up from space. That means whatever's causing them lies deep enough to evade orbital scans, yet shallow enough to affect surface instruments. Bottom line, until we land and dig, huge parts of the Moon remain invisible to our best eyes in the sky. Chandrayaan-3 proved that orbital data isn't enough. What you see from 100 kilometers up may not match the reality on the ground. From now on, truth means landing there. The old plan, map, survey, mine, build, is no longer so simple. If hidden forces lie beneath the regolith, drilling could trigger radiation bursts, tremors, or collapses. Even solar power isn't safe. PN's panels showed output drops unrelated to sunlight or shadows, hinting at strange environmental interference. Scientists suspect electrostatic weather, where charged dust levitates and disrupts systems. On a world with no real atmosphere, this kind of invisible hazard could cripple operations if we don't figure it out first. If electrostatic weather is truly at play, it means the Moon's surface isn't as static as we thought. It's alive with invisible movement. Charged dust could coat sensors, jam moving parts, and even short out electronics in habitats or rovers. Over time, it might erode seals, scratch visors, or block radiators, threatening both human crews and machines. Worse, in the anomaly zones, this dust may behave differently, clumping, dispersing, or carrying strange charges that amplify the radiation and EM interference already detected. Chandrayaan-3 may have stumbled onto a chain of interconnected hazards, each feeding into the other. If that's true, then mastering the South Pole isn't just about landing there. It's about surviving its hidden, hostile systems. Survival in these zones will demand a whole new generation of technology, not just stronger shields, but machines that can adapt in real time to shifting environmental threats. Future rovers may need self-cleaning surfaces to repel charged dust, habitats with dynamic EM hardening, and power systems that can switch instantly between solar, nuclear, or stored reserves when output drops. Astronaut suits might need built-in radiation burst alarms and dust-repelling fabrics. But the biggest challenge isn't just hardware, It's knowledge. Without a complete map of these anomaly networks, every step on the moon's south pole is a gamble. Chandrayaan-3 hasn't just expanded our understanding. It's drawn a line in the regolith between the explorers who adapt and the ones who fail. In these anomaly zones, Chandrayaan-3 detected dust behaving in ways no one expected, tiny grains floating like an invisible fog, clumping together as if magnetized. This isn't just a nuisance. It could wreak havoc on delicate instruments, blur camera feeds, jam airlocks, and wear down moving parts. Apollo already proved lunar dust is dangerous, but this strange, reactive version takes it to a whole new level. If it's truly cohesive or self-aligning, it could throw off both robotic and human missions in ways we're not ready for. The moon's south pole has just rewritten the rulebook, so subscribe, like, share, and drop your thoughts in the comments. Because this story is far from over.